Okay guys, now we can see the addition of absolute value functions. That means if you are given the graph of this type where two absolute value functions are to be added. Added means this sort of addition we have to show in the graph. So in order to draw the graph, just first of all get it ready. So this is x-axis and this is y-axis, this is 0. Now we work individually for these two graphs. So here, in order to draw that graph, so first of all we consider y equal to absolute value of x plus 1 only. So you should know that how to draw this graph individually. So this is the graph, and this point will be -1 and 0, and this point will be 0 and 1, because when x equal to 0, y is going to be 1, that we have already seen before. And we'll keep the enough length from both sides of the v graph. Now you can see another function that it contained with is absolute value of x minus 1. So we can draw the graph for this x minus 1 also, and its vertex will be, because it is -1, so it will shift one step right of this origin. So the coordinate of this point will be 1, 0, and your graph will be like this. Okay. Now what you need to do, actually, will divide the whole graph, combination of whole graph, into two parts, so that you can see here, like this part of the line falls outside of the boundary, which is represented by this dotted line, and here also these two parts of the line is outside of the left boundary. So here these two lines are parallel to the y-axis. That means this line falls perpendicular to the y-axis. Why we are taking this reference? Because we are going to add these two lines together to form a single graph for whole function. So here what we can do, actually, if you have look at equation of this line, so this is the graph for the second constituent part of this function. So equation of this line will be y equals to x minus 1. Then and in another graph, equation of this line will be x plus 1, because it has acute angle and coefficient of x is 1. That means gradient is positive, therefore it has acute angle. So this is the equation for line x plus 1. Now what about equation of this line? Equation of this line is going to be, actually the green graph is for the second constituent function. This is x minus 1. So yeah, so we shall take from here x minus, gradient should be negative here, because it is making obtuse angle from the x-axis. So that equation of this would be minus of x minus 1, and after you solve it, it is going to be minus x plus 1. So we have got the equation of this line as minus x plus 1. Similarly, we have got equation of this line, this line, this line. Now we are left with equation of this line. So this line is the part of absolute value x plus 1. So part of this, in the part of this function, this line is making obtuse angle with the x-axis. That means its gradient should be negative, therefore its equation is minus x plus 1, that is equals to minus x minus 1. Now as we are adding these two graphs, so first of all we add the lines right of this boundary, and we'll work like this. So first work that we are either we can work for outside of this boundary or work for inside of this boundary. So first of all, I am going to work for inside of this boundary. So inside of this boundary, you can see equation of this line is x plus 1 plus equation of this line is minus x plus 1, and if you solve it, plus x minus x is going to cancel, and then we have total 2, and this is the value of y, because this is y equal to x plus 1. Alright. Similarly, we'll do the same work to the left side of this y-axis here, but within that left boundary. So here the second work is equation of, you can take either equation of this line is, you can see here, minus x plus 1. Equation of this line is minus x plus 1, because we are working for inside these boundaries from either side of this y-axis. So equation of this line is what we have taken here, equation of this line is minus x plus 1. Then you have to take equation of this line, which is x plus 1, which is x plus 1. In this case also, x and x got cancelled out, so value of y is 2 now. So here the coordinate of this point is going to be, this is 1 and y is 2. Also, if you put y x equal to 1, you will get y equal to 2. So what will be this value? This coordinate will be minus 1 and 2, because in this equation, if you put x equal to minus 1, so minus 1 minus 1 is plus 1, and 1 plus 1 is 2, so value of y is 2. So this we have done the inside work. Okay, now we shall do the outside work. What happens outside work? And you must understand the story of inside and outside work means inside and outside. So we are adding all the line within this boundary, part of line within this boundary, and part of lines beyond this boundary. So now we'll work to add the part of line outside of this boundary. So for the outside of this boundary, you can see here one equation is x minus 1. So equation of this line is x minus 1, and equation of this line is, you can see here, this is x plus 1. So it is going to be x plus 1. So before I further go to this sort of thing, what I can do is I will take a bit up, this sort of boundary a bit up, and then I'll join these two lines. Okay, so if I join these two lines, then what happens? It will be the equation of the line. If you see it outside, it is going to be y equals to 2. So it is going to be y equals to 2, and why it is taken between minus 1 and plus 1, because we have worked between minus 1 and plus 1, because this is the work for within these two boundaries that contains x values as minus 1 to plus 1. So now we are adding the line outside of this boundary. So I am taking from this right side, so it is x minus 1, then it is x plus 1, and now it is going to be x plus x is 2x, minus 1 and plus 1, they got cancelled out, so this is 2x. Now let's consider to this line. This is x plus 1 and its coefficient is plus 1, and here in the resulting y the coefficient is 2. So that line will start from here. As the coefficient of x is greater than 1, it will be little bit lean towards y-axis. Similarly, if you do the outside work from this side, so equation of this line is minus x minus 1 plus, and then equation of this line is, what is there, minus x plus 1, minus x plus 1. Now here minus 1 plus 1 cancel out, so y is equals to minus 2x. You can again see here equation of this line is minus x plus 1. So you can see here the coefficient of x is -1, but here coefficient of x is -2. So the line will go little, it will stretch little towards y-axis, then the line -x plus 1. So this is the final graph for our equation. So let me draw the final graph that we have got it from here. Okay, so you can see this is 0 and our graph was like this. Yeah, so this point is actually, this is y equals to 2, so this is 0 2, so this point is going to be 0 2, and this point is 1 2, and here it is -1 2. Okay, so this is the graph for the function y equals to x plus 1 plus x minus 1. So this is x-axis, this is y-axis. Okay, if you would like to check it in the graphics software, you can do so also. You can see what kind of graph we can obtain from here. So we don't need to write all the steps that we have done here. It looks a bit messy, but our final graph is here. So we can just type this function into the graphics software. So first of all, I'll write here absolute value. I press absolute value, then it is x plus 1, so it is x plus 1, then outside the absolute value, then plus again the absolute value, yes, and then another function is x minus 1, so it is going to be x minus 1, and then you can see the graph, and you can also read off the coordinate of each point. So here you can see, as in our graph here, this point is, it is showing that this is 0 2, and our point is here 0 2. Here also you can see it is 0 2. You can see this nicely. Now we shall check about this corner points also. It's not displaying here, but I can read it from the graph that it is 1 unit right and then 2 unit up. That means it is 1 2, and from the left side also this is 1 unit to the left and 2 units to the up. That means it is -1 2. So here in this graph also we have -1. Okay, now after the addition of the graph, we shall draw graph of this kind of function. So its topic is subtraction of absolute value function. Subtraction means due to this negative sign. So here what we will do, actually, instead of subtracting the thing, we'll transform that into the addition. How is it possible? It's very simple. You can write y equals to x plus 1, then instead of minus we can write here plus, then inside the bracket minus absolute value of x minus 1. So although we'll be adding these two graphs, we will be subtracting these two graphs, but it will look like as if we are adding them. So here, just like before, we'll get our graph ready. x-axis and this is y-axis. So now you can see here in this case it has also two functions, one as absolute x plus 1 and another function as minus absolute x minus 1. So first of all we draw these two graphs separately. So here, just like before, I'll draw the graph like this. So this point is going to be minus 1 0 and this is going to be 0 1. Now you can see here, as this is minus 1, the graph will be at this position, that is 1 0 position. But due to this negative sign, instead of going this graph off, it will be just inverted graph than before. So how it will be actually? It will go like this. So the space is not enough here, so I'll take some more space and then the graph will be like this. Okay, I'll take the enough space, the graph will be like this. Now we shall, let me change the color so that it will be clear. Okay, yeah, so this is the inverted graph than before. Now in that case, what we can do, we will do the same work, that adding outside of the line and adding inside of the line. So I will draw a vertical line from the x-axis that will go to meet the another line. So from here to another line. So in that case we can do the work either from inside or from outside. So first of all we'll write the equation of the lines. So this is the equation of line where the gradient is positive here. So in order to make the gradient positive, it should be minus. So it is minus of minus x minus 1. So equation of this line is going to be minus minus plus, so it is x minus 1. So this will be the equation of line x minus 1, because this coordinate, if you read off, it is going to be 0 minus 1. Okay, now what about the equation of this side? Equation of this side will be with no sign change. So it is minus already here, and then inside the bracket it is x minus 1. So that gives you y equals to minus x plus 1. You can see that the gradient is negative, that means it is making obtuse angle with the x-axis. Okay, similarly we shall click on the equation of this line. This line is going to be x plus 1, y equals to x plus 1, and this line is going to be y equals to minus x plus 1. Okay, now minus x plus 1 means inside the bracket minus x plus 1. So it will be finally minus x minus 1. Now in this case we'll adopt the same strategy to add these two graphs. So here first of all we shall add the graph from outside of this boundary, or also if you like you may start from adding the lines from inside of this boundary. So at this time I am doing the work from outside of this boundary. So first work is that equation of this line is x plus 1 plus equation of this line is minus x plus 1. So that is going to be minus plus x, and minus x cancel, so y value is 1 plus 1 is going to be 2. So here the value of y will be 2 and x is 1. So what we can do here, as we have added the things from outside of this line, therefore we have done the work for x is greater equals to 1. That means our line will go this way, and this line will be y equals to 2, because the value of y, coordinate of y is 2 here. Okay, now do the same work from another side. So now I think we need a bit more length here, so let's check what is happening here. Okay, so a bit more extension in this line. Yeah, a bit more extension in this line. Okay, so this line is also perpendicular to the x-axis and is parallel to the y-axis, and this we have taken for the reference only. So here also we shall talk about the part of line outside of this boundary. So in that case, you can see here our second work is to add this part of line to this part of line. So equation of this part is minus x minus 1 plus, and then equation of this part is, you can see, x minus 1. So this is x minus 1, so plus x minus 1, and then minus x plus x, they are going to cancel, so y equals to minus 2. So this point will be y equals to minus 2. That means y equals to minus 2 and x is minus 1. Okay, now as we are adding the part of line where x is less or equals to minus 1, so at this point our line, another line will be like this, and this will be the equation of y equals to minus 2. You can see this is the equation of y equals to minus 2. Okay, so final graph is still not ready. Now we have already done the outside work, we shall do now the inside work. Yes, so in the inside work I am taking this as third work. So you can see in the inside line to the inside of this this boundary, equation of this line is x plus 1 plus, and equation of this line is, what is that? You can see here x minus 1, so that is x minus 1. So your work is going to be x plus x is 2x, plus 1 and minus 1, they got cancelled out. So your equation of line would be y equals to 2x in this case from for inside. So if you compare this line with equation y equals to mx plus c, y equals to mx plus c, your value of m is going to be 2 and value of c is going to be 0. That means your line will pass through origin. That means our line will be here, this is O, so our line will pass this way. So if you join them, your final graph will be like this after being added both the functions. Both the function means these two functions. Okay, so this would be the final graph for our equation. And if you consider only this, so equation of this line is y equals to 2x, that means its gradient is positive 2 and there is no plus value, there is no c value, that means the line will pass through the origin. So let's draw the final graph. So let's display the final graph separately. You will have graph like this. One line will pass through origin and then it will be parallel to x-axis towards along the positive direction, and also it will be parallel to the x-axis along the negative direction, and your graph will look like this. If you read off all these points, this is the origin, and if you want to read this point, this is 1 2, and if you read off this point, this is -1 -2, and this is the graph of and this is the final graph of the given function absolute x plus 1 minus absolute value x minus 1. So this is the graph of this function. So in this case, first of all, you have to draw the graph of these two functions individually, then try to add those the lines obtained through the graphs of those two absolute functions separately, then divide that into two parts. So add the part of graph from outside where you usually get the opposite gradient, and then from inside you will get the gradient along the same direction, and if you add this way, your final path will be like this, and finally you can display your original graph to the separate graph paper. Or you can do this sort of work in your rough area, and then you can copy the final graph into your main answer sheet. Now while learning, this is important to check the graph through any graphics software. So let me check that also. Okay, so here I am going to type first of all the whole thing. I am not going to type everything individually here, so I'll plot whole graph at a time on this graphic calculator. So it is absolute x, then plus 1, absolute x, then plus 1, and then after that you can see it is minus, so it is minus. Okay, then see it is minus, then again absolute value sign, then it is x minus 1, so it is going to be x minus 1, and our graph is ready like this. Now you can compare these two graphs. Okay, so both the graphs look like same. Now you can read out the point. The graph has passed through the origin. So here also it shows that, here also it shows that this graph passes through origin. Now this point is 1, 2, so let's read off this point here. Okay, so to the left it shows that, it shows that 1 unit, to the outside it is 2 units, therefore coordinate of this point is 1, 2. So here also the coordinate of this point is 1, 2. Here if you go to this point, you can count 1 unit left here and then 2 units down. That means both are negative values, so it is minus 1 and it is minus 2. So y is minus 2, so x coordinate is minus 1 and y coordinate is minus 2. So this explains that how to subtract the graph of absolute functions. Now I have some classwork for you. If you would like to do that, it will be better if you do it now. So here it is, the classwork. You can see, using the graph of y equal to under the absolute sign x plus 1 plus under the absolute sign x minus 1 in part 1 that we have just done in the work number 1 here, and after using that graph you can solve this equation. Okay, next here in this graph you have to simply draw this graph only. For all x means x belongs to the real number, that is negative infinity to positive infinity. Now here in this case you can see graph the function y equal to under the absolute sign x plus 2 minus under the absolute sign x minus 3, and hence solve the equation this. Here you can see how many solutions exist, whether there is only one solution or two solutions. You have to find it out. So that's all for now.